hash maps are one of the, I don't know, like the best, well, I mean, best is a strong word, but it's one of my favorite data structures that we have in Rust. It's very similar to what we might see as like a dictionary in Python or just a plain old object in JavaScript. The way we can think about it is it's exactly like that JavaScript object. So it's represented by curly brackets. It has a key and value pair. And then there's a bunch of methods attached to it for getting and manipulating and, you know, all the normal stuff that you'd expect to deal with something that looks kind of like this behind the scenes. So let's get into like some of the cool things we can do with hash maps. So to begin with, anything can be the type here. And when I say that, I actually do mean anything can be that type. In a previously, we used a hash map and we put the type ID in there. What we can also do is we can have like an enum, for example, be the type. So let's take a look at what that could mean. So let's say I have an enum, and the enum could be just basically, I don't know, letters. So we have A, B, and C. Okay, great. Interesting letters. These can actually be the keys for something. And then we can have our values, which maybe will just be like A, B, C, and you know whatnot. So if I want to create a hash map, so that our hash map equal to hash map. Now hash maps do need to be brought in, so we'll notice that it's brought in from collections. Unlike vectors, they're not used so often that the standard library just basically adds them to the prelude and makes them available everywhere. Okay, so I'm going to create a new hash map. Also notice that Rust Analyzer is telling me that the hash map type is unknown right now. If I left everything like this, I would start getting errors because it doesn't know how much memory to set aside for this hash map. Basically, as I start using this, it's going to figure out the types, but until then, I'm just going to have to live with that error. Okay, so if I want to insert something, inserting this pretty easily. It's going to do hashmap.insert, then this key and value. And so let's say I want this letters, like a arm of this letters as the value, as the key, sorry. So that's going to be letters A. So we can actually see that letters is now the key. And then the value, let's just say that you're characters. So you're an A. So a char is the value here. This could also be a vec of like char. That's also a possibility. It wouldn't be a vec like that. It'd be a vec like that. Basically, and we see that it updates itself. It figures out what it's supposed to be. We're just going to come back and make this good old, let's make you a, yeah, let's do the vec. Vecs are nice because we can like see us manipulate them and change them. So we'll do a vec of like A over here. Okay, so this is fine and great, except we do get an error here. The error is, hey, letters, this enum, the trait bound for equal is not satisfied. So equal is not implemented for this. Well, if I want to like make this now actually usable as a key, that's perfectly fine. I can just derive equal like that. And then I need partial equal. And I believe one last one is hash. I need hash. By doing all of these, we're now fine. And I actually think, can I get rid of the equal and just do partial equal? No, okay, I need equal. And so now what's going to happen is, as it compares the keys to each other for our queries and to make sure that you're not inserting something exactly the same, it now knows, hey, this is this is what the A arm of letters is compared to the B letter. And because of that, we can now use letters as a key in this hash map. So as long as it has this equal, partial equal, and hash traits assigned to it, we're good to go. What this means that if you have a custom type in which it's not so easy to derive equal, partial equal, and hash, then you can implement those yourself and then still use them as keys, which is really amazing. It's one of my favorite things we can do in Rust. Okay, so we have this vector as an A in here. If let's go ahead and also put a debug on this, because we can debug this hash map and take a look at what it looks like behind the scenes. Basically, it here's our hash map. It's this open and closed curly brackets, and then we just see A, and it's this vector of, well, the character A. Kind of what we expected, but it's really nice to sort of see it, displayed out for us here. All right. Now, insert is not the only way of getting things into here. There's another method, which is another really interesting method. It's shown in the Introduction to Rust book, if you've read that. Basically, let's say we want to add something in, but we're not sure if it exists. And if it does exist, we want to get access to that so we can update it. If it doesn't exist, we want to just add something new in. Well, entry allows us to do that. So if I do something like let I don't know, my letters equals hash map, we can do entry. It takes in an actual key here. We notice that it takes ownership of this key too, which is not bad in this case. So letters, let's do letters B. And that gives us this entry here. But what I can do is I can say, well, what if I do or insert? So if there isn't a letters B that I can get back, I want to insert a vec with B inside. And that way I now have a mutable reference to the vector that has B in it. So I can actually add another thing in here. So I can do letters. Let's push BB. And now when we do our debug out, there was an error. Oh, I can't do BB. Let's just do another B here. If I run this, we now see that we have B with two B's inside of it. So the first one was that or default, and then the second one added another one in there. Okay, great. So this is great for if you want to count lots of things, and you're well, the first time I see it, I want to insert this with a 0 in it, and then I want to increment it by 1. And so if you're doing a dictionary lookup inside of a book or something, and you want to count the number of words or count the instances, this is a really, really great pattern for that. Let's see. We also get this warning here, which I believe we can just have Clippy change to. It wants us to do or insert with, and then have a callback function here. And that's, I believe, because the callback function, or the closure in this case, is it will run at runtime and basically take a little bit less memory, because it's possible that this doesn't need to run. It's if it finds the letters B, it's just going to return that, and then the or insert with doesn't happen at all. This only runs if it can't find anything. All right. Now, getting things out is I mean, pretty simple. We can also take a look at like what the length is. So length is not just something that we only have on vectors or arrays. We can actually just do a dot length here and see what the length is. Its length is 2. Now, the length has nothing to do with how many items are in these vectors. It's how many key value pairs there are. So we have 2, A and B. If I want to just get a specific thing, I can't do what like JavaScript does, where I can just put like square brackets or use dot notation to sort of like reach into the object. There is a method that I have to call to sort of get it out. So let's say I want all of the A's. I can do let A's, so A equals HashMap, we're gonna get, and then it wants a reference to the key. So a reference to something like the key. In this case, I'm gonna do letters A. Now this gives us an option here. So because it's possible, what if we're going for C? If we're going for C here, we know that we're not gonna get anything out, it's gonna be a none. With an A, we know that it's gonna be something here, but that's only because we hard-coded adding something in. If we're dynamically adding things into this hash map, well, we don't necessarily know what's gonna be inside of it at any given point of time. So if I do this, we get an option. At that point, we can unwrap. We're sure that there's something in it, or we can do the if let sum pattern in order to reach inside and grab something out. We can almost imagine that this entry was kind of sort of like that, except just, you know, in line. So I could then unwrap this, which will cause a crash if it can't find the key here. But now I have this A. We notice it is a reference to whatever the value is stored in this. And then I can also do a get mute in order to get a mutable reference to the value. And that's true for almost all of the methods here. Is there's almost always like a mute version and an immutable version. And generally speaking, just go with the immutable version unless you really need mutable access. Another way that we have to get access to the hash map is doing some just doing a loop through it, and we can just do a normal loop. So we can do a for, and then if I try to do something like, well, let's do like values, like maybe letters, in our hash map, you'll notice that it actually responds with a tuple here, where we have the letters and then, well, the vec of characters. So let's change this around. We'll have letter and characters. So a normal for loop, and it runs the normal iterator basically just returns each key value pair as the tuple. So we can now just like, we can actually figure out what the letter is and the character is and do whatever we want to do with it. Because of that, if I want to use any of the higher order like methods, then I can do that as well. So I can do HashMap, iter, and then we can just do it like a for each. And that for each, we give it a predicate, and then you can see that we have a tuple with letters and the characters here, just like with the for loop. So I can actually put this in here. And now if I want to like just debug, let's say, I don't know, characters, and that's it, and we're done, this is perfectly possible and something we can do. Oh, I'm not supposed to return anything, so let's do... Debug actually does return something. That was outside of there. Go inside. There we go, semicolon. So anyways, using iterators, like really easy in HashMaps, and just like it kind of makes sense and is very familiar to like the other things that we have in Rust. There's other iterators that we can use. For example, let's say we really don't care about these keys. We can run, instead of iterator, we can just do values. Values, and then at that point, we don't need this tuple anymore. It's just the values, so it's just these characters. And then we can just do the rest because it's just a different type of iterator now. It's just an iterator over the values themselves. And now in this case, it's still a reference to the values, but you can get values mute. And then the final thing is sort of like in like reading into the hash map and sort of like seeing it that I want to cover here. There's plenty more in the documentation, which I would highly recommend checking out if you're interested in learning a little bit more about hash maps. Is you can actually just check to see if the key exists. You don't have to iterate through it and then just like check each one, say, hey, if this, then like break when we find it. What we can just do is say something like if like letters A, so let's see, is letters A. Actually, it's gonna be a little bit easier than this. We're gonna do if hashmap dot contains key letters, and it's a reference. So I do need to reference this like that. Then maybe we're just gonna like debug. We have A's. That's actually like, that's just a way for us to find a Boolean. We don't have to loop through that just to find out if something exists. When it comes to updating, there's some other really interesting methods here. So let's say that I'm perfectly fine having like, the A's, but I don't want anything that's like not A's in here. Retain is a method that's both on vectors and on hash maps. That's really, really, really nice because it's sort of like a filter, but it's in place. Meaning that if you want to just get rid of everything except something that's based upon a predicate, you just run retain. So we can just do hashmap dot retain. And we can see here, it takes in a function and retains only the element specified by the predicate, and it's gonna give us the key value, I believe. Is that it? Key and value returns false. So we can actually see, yeah, the key and value here. Now, if are you yelling at me? If I just say like false and return false every single time, you're going to be upset. The closure expected has two distinct arguments. Oh, it's not a tuple. In this case, it passes key and value separately. That is something that can be a little bit annoying sometimes, is that HashMap does change whether or not they're passing in the key and value separately like this, or in the tuple when we do like just the for each, the for each of like a normal iterator. But it's perfectly fine. It's like the compiler will gently remind us, hey, just don't do that. So here's like our keys, our values. If I return false, at this point in time, we can now test the length to see how many items are in here. So let's do another debug of hashmap.length. After we run our retain, we run you, we'll actually see that our length is now 0 because we removed everything. So if I put in a true here, everything would be kept. And just like a good old filter, if I had some kind of logic where I reached in and say like, hey, if you have this thing in you, then return true, otherwise return false. And I'm only keeping what I really want to. And then we have the delete methods. So the two that I'm sort of like use the most often, remove just removes the value based upon the key that's added in. So that would be like hashmap dot not retain, remove. It takes in a reference to the key, and then it's going to return an option with the value that we did remove. Almost always, like, we don't have to consume that option. You can just sort of like leave it blank. So if I were to remove, let's remove B. So letters B, make that a reference. Let's go ahead and not do our retain here. I can just do that, and the compiler won't yell at me saying, hey, you have this option you're not using, you have to use that. So anyways, I sort of think that's nice, and it's nice to know that you don't have to always consume every option or every return statement. And then finally, if we just want to like empty out our hash map in case like we want to reuse it for some other purpose, there is a clear nuke method. So we can just do hashmap.clear, and it's all gone. Everything's gone. It's no longer available to us, and we have to start over with it, which sometimes is exactly what we want. Anyways, there's a lot more to hash maps, but these are the basics, and these will get you going. And I believe this is all we need for the project. Now, I highly recommend, if you're really interested in this, to dive into the documentation. The Rust book has a great chapter on hash maps, and also there's a great page on the hash maps in the official docs. So anyways, hope you enjoyed this, and I will see you in the next video. Bye.